So let's see first chemical properties of amines. Only few are there. So let's wind them up quickly. So the next chemical property is Hinsberg test. Hinsberg test. In this, we'll use some sort of a compound C6H5S double bond OCl, aryl sulfonyl chloride. Aryl sulfonyl chloride. We are going to use this type of a compound in the Hinsberg test. So what is the purpose of conducting this test? Means this is the best test to distinguish between the difference between the primary, secondary and tertiary amines. So with the same reagent, primary amine going to act in some way and secondary one in some other way and third tertiary one in some other way. So basically we can use this one to differentiate the difference between these three sort of amines. So let's take our main reaction. Let's see. So first let's take our primary amine. C2H5 or CH3 anything, NH2, and our compound aryl sulfonyl chloride C6H5 S double bond O S double bond O Cl. This is our primary amine. This is our aryl sulfonyl chloride. So what happens here? As this is a good leaving group and this sulfur is surrounded by oxygen. So what happens? This oxygen attracts the bond electrons towards itself and they again back bonds. So this sulfur got a partial positive charge as it is surrounded by two electronegative elements, Cl and oxygen. So it is desperately needs electrons. So at that point, who will come and help this sulfur? This nitrogen with its lone pair of electrons. So this nitrogen donates its lone pair of electrons to sulfur and forms some sort of a bond. So how it's going to look? C2H5N positive as it is donated its electrons. NH S double bond O, S double bond O, and one more aryl group, C6H5. So as this sulfur is surrounded by oxygen and chlorine, as chlorine is a good leaving group, it goes out and this oxygen back bonds, first of all, it drags the electrons towards itself and again it will back bonds the electrons. So at this stage, sulfur is partially positive, so it desperately needs electrons. Those electrons are given by this nitrogen having lone pair, forming such sort of a bond. Now here nitrogen is having positive charge, so it also requires electrons. So this bond will break that. At this time, the hydrogen will come and help in this case. So it gives its bonded electrons to nitrogen, and with this Cl, it goes out as HCl, minus HCl. So now what happens? C2H5, as this bond is broken and the electrons came to nitrogen, so positive charge obviously goes out or vanishes, forming such sort of a compound. If we conduct this test in a basic medium, so NaOH or KOH, any base, what happens? This compound is soluble in this NaOH. Why? Due to the presence of this acidic hydrogen, this compound is going to soluble in NaOH. Why? Because we know this NaOH splits into Na plus and OH minus. This OH minus goes to hydrogen and drags this out as water. Before going out, this hydrogen, what it do? It gives its electrons to nitrogen and the bond is going to break. At this stage, nitrogen is having negative charge. So this Na plus will come and help the nitrogen, forming one sort of a salt. So finally, what's going to happen? C2H5 N minus, and this H goes out with OH minus as water. So N minus, S double bond O, S double bond O, C6H5 and Na plus. Due to electrostatic force of attraction, this comes nearer to N minus, resulting some sort of a salt. So, by observing this reaction, what happens here? Two steps of reaction is occurring in this case. First step is with this one. Primary amine reacts with aryl sulfonyl chloride, that is first step. Again, the second step is reaction with NaOH. And finally, forms such sort of a salt with sodium. So this is in case of primary amine.